Hey everybody, welcome back. Today we're going to have our final lecture on the normal distribution. We're going to talk about the inverse norm function, which is a calculator function in the same location as normal CDF, but it does the reverse of what normal CDF does. So you're going to see a bunch of questions that use that calculator function. And that's going to conclude this initial topic on the normal distribution. Let's get started recapping what we know about the normal distribution. It's a continuous probability distribution, so it's used for continuous variables. It models many real-life data patterns. So by real-life data patterns, we see the normal bell-shaped continuous distribution with many things like IQ and blood pressure and height and weight. And because these things are normally distributed, because these variables are normally distributed, we have the mathematical ability to make predictions in the population about those variables. It has this characteristic bell shape, and that's why we call it the bell curve. And the probability of something happening with the normal distribution is equivalent to the area of the bell curve that corresponds to that event. And this is why it's so powerful. We can estimate probabilities by using normal CDF, the mathematics that help us figure out the area between 2 points underneath the bell curve. Okay, and normal CDF is actually just using calculus, and instead of doing the calculus manually, we tell our calculator to use normal CDF, and it does the calculus for us. So we can find the area between any 2 points, for example, A and B, and that area translates into the probability of an event happening in the normal distribution. Inverse norm. Inverse norm is found on your calculator right beneath normal CDF. It's number 3 on the list. And what it can do for us is find the value, also known as the data point, find the value in the normal distribution that corresponds to a given proportion or percentile. So let's take this piece by piece. It reverses what normal CDF does. Normal CDF gives us the proportion or percentile based on values in the distribution, and inverse norm does the reverse. It gives us a value in the distribution based on the proportion or percentile. Okay, so it works in reverse compared to finding probabilities. So instead of starting with a data value or more than one data values and finding the area underneath the curve between those data values, instead of starting in that way, we start with the area first, also known as the proportion. And based on the area, we find the data value. So let's take a look. Questions using invNorm could be phrased like this. What is the score that separates the top 10% of students on a test? So the question is not asking for probability or proportion of area. It's saying what is the score? So it's asking for the data point, the value in the distribution. And it's giving you an area. Top 10% represents a piece of the curve, and we'll shade that in to get a better view of what it looks like. But that represents the area, and you're being asked to find the data value. So when you're asked a question in reverse like that, we use invNorm, inverse norm. Here's another example. What blood pressure? Again, that's not asking you for a probability. It's asking you for a value, a data value. What blood pressure corresponds to the 90th percentile? Now, the 90th percentile is another way of saying we can rephrase it as the bottom 90%. Okay, so it's giving us area in the form of a percentile, and it's asking us for a data value. So we use inverse norm. Okay, we need 3 inputs with inverse norm. If you open it on your calculator now, you'll see that it's asking you for an area, and you could specify the direction as left, right, or center between the two values. Now, on our version of the calculator, we do have this option of left, right, or center. On older versions of the calculator, you don't have that option. So if you are using an older version of the TI-84, I put in Brightspace, I put a document that you can use to answer these kinds of questions, because the calculator is still capable of answering these types of questions. It just looks slightly different than the way I'm going to show you with the TI-84 CE that I required in this class. Okay, you will also be provided with a mean, okay, and inverse norm will take that value in as well, a mean for the normal distribution and the standard deviation, how spread out it is. So you'll be given these 3 things, and you'll put these 3 things into inverse norm. And this is what it's going to look like on your calculator. Your area needs to be put in the form of a decimal. You're not going to leave it as a percent. So 10% has to be put in as 0.10. And the mean and standard deviation, as we saw with normal CDF. Where it says tail, you specify the direction, left, right, or center. The function will give you in return, it will output the data value in the distribution that corresponds to that cumulative area. For example, okay, so if we put in 0.10, 0, and 1, and we do left, we are going to get out negative 1.28, and that would be a z-score for the 10th percentile. Okay, I'll make a quick picture for what this looks like. It's always good to make a picture when you're learning this. Okay, based on the input up here, our area is 10%, and we're shading left. So we're going 10% on the left side. So that's what we're being asked, or that's what we're being provided. And what the calculator invNorm is going to give us is the data value that's at that cutoff point, that dividing point between the bottom 10% or the leftmost 10% and the top, this would be the top 90%. invNorm gives you the cutoff between those two areas. And that negative 1.28 makes a lot of sense in that case because it's a z-score and anything on the left side of 0 is negative. So how does invNorm work? Let's look at a question. Blood pressures are normally distributed, so build a bell curve. Find the z-score. Okay, so this question is dealing with z-scores where we know the center is 0 and the standard deviation is 1. And we are being provided with more information that we're asked to find the z-score for the blood pressure at the 10th percentile. So we have the z-score, that's what we're being asked to find, and we have the area, the 10th percentile. And you have to know coming into this question that percentile means the leftmost area from the data value. So you're going to make a picture where you shade in the bottom 10% because percentile always refers to the left. So 10% of area, try your best to come up with a decent picture. And what this question is asking you to find is this z-score right here. Okay, what's that z-score? So after using inverse norm, we get out the z-score negative 1.28, which makes sense because it's on the left side of 0. And that z-score cuts off the bottom 10% of area of this curve. Okay, so when we're asked for values out of inverse norm, if they're z-scores, we're going to round to 2 decimal places like we have here, negative 1.28. And a lot of other data values, we will also round to 2 decimal places. And in some cases, we're going to convert that to a whole number, a percent, and then we'll multiply by 100, we'll convert it to a whole number. Those are questions involving percentile ranks. So let's take a look and see the various types of questions that we can see or that we may be provided when doing questions in invNorm. Okay, let's look at a question involving z-scores and weights of newborns. The birth weight of a full-term newborn is normally distributed. Find the z-score that. Okay, so the question is not asking us for a probability or a proportion of area. It's asking us for a z-score, so we know that the right tool to use is inverse norm. Cuts off the bottom 15% of newborn weights. Cuts off the top 2.5% of newborn weights. Cuts off the middle 80% of newborn weights. I just want to phrase that, make note that the phrase bottom 15% is also equivalent to saying the 15th percentile, because percentile refers to the area on the left, and that's what the bottom is. So part A could have been phrased as the 15th percentile. You want to be able to read the question and recognize that those are the same things. So with part A, the bottom 15%, the area that we want to shade in is the leftmost 15% of the curve. It doesn't have to be to scale, but you want to try your best. And the vertical line where you cut off that bottom 15% marks the z-score that you're trying to find. So the z-score in question is right at that dividing point. Now, because it's the bottom 15% and 15 is less than half, because half of the bell curve is 50%, 15 is definitely less than half, you want to make sure that the shaded area that you create in your picture looks like less than half of the curve. If you made your vertical line over here and you shaded in everything to the left of that vertical line, that would be incorrect because that is clearly more than 50%. We have to make our area appear less than 50%. It has to look like 15%. So let me get rid of this bad picture here. Okay, and so this peak picture, while it may not be to scale, it's reasonable because the shaded area is less than 50%. So I'm going to go to invNorm and I'm going to put in my area as 0.15. That's 15%. I want to use mean of 0, standard deviation of 1, because when we have problems involving z-scores, that is what we use for mean and standard deviation. And I did explain why in a previous lecture. I think it was the one just before this. So you can review that lecture if you need to. We shade in the area on the left, and that's why we choose for tail, we choose left. The left tail is the bottom part of the curve. We paste that and hit enter, and we get a z-score of negative 1.03. Now, I didn't do it on the calculator actually with you, so let me do that and show you exactly what it looks like when we do this on the calculator. Okay, we are going to click second and distribution. Number 3, inverse norm. area, we're going to put 0.15 for 15%, 0 and 1, and shade on the left. If we want to change this, by the way, we just scroll, or use your arrow to the right or left and hit enter, and it would set that other direction. So we want to make sure ours is left, and then paste, and then enter. It brings it to the home screen. Then you hit enter again, negative 1.0. Oh, it looks like I rounded incorrectly. Negative 1.04 is the correct answer. So when we go back to the slideshow, let's fix that. Negative 1.04. Okay, so let's fix this. Negative 1.04. Okay, second part of this problem said find the z-score, and it also has in parentheses s, because some questions you are going to be asked for two z-scores, and this is though just one z-score. The top 2.5% of newborn weights. There's only one z-score that cuts off the top 2.5% of newborn weights. Visually, let's look at the picture. The top is on the rightmost side. So if we shade in the where is it? My picture doesn't have the shaded in area. Let me try here. Let's try to shade in our topmost 2.5%. That's the right side. And when you put 2.5% in as your area, you're going to make sure that it's 0.025. So some students need to be reminded exactly how to do that. 2.5 expressed in decimal form is 2.5 divided by 100. And if you do that on a calculator, 2.5 divided by 100 is 0.025. Okay, so that's the area that you put in right here. Mean and standard deviation are 0 and 1. And you're shading to the right this time. And I'm getting 1.96. Let me go to the calculator and make sure that's correct. Okay, second distribution, inverse norm, 0.025, right, and go down to paste and hit enter. And rounding this to two decimal places, 1.959 becomes 1.96. Okay, so we know how to find a z-score when the area is on the right side. And from the previous problem, we found a z-score where the area was on the left side. And now the last question we're going to look at is when the area is in the center. And back up here. Notice on the calculator, we do have a center option. That's the one we're going to use now. So the question is going to be phrased like this. Find the z-scores, and here we have the parentheses around the s because we are going to find two z-scores in this case. That cuts off the middle 80% of newborn weights. So we're looking at the very center of the curve, and we're going to shade the center 80%. So when you shade the center 80%, it's supposed to look symmetrical as best you can. So the z-score that you're looking for on the left-hand side and the z-score that you're looking for on the right-hand side are negations of one another. They'll be the same number, but on the left it'll be a negative and on the right it'll be a positive. And that's because the bell curve is completely symmetrical. So we're going to use the same function, inverse norm, with an area of 0.8. And to do this, this calculator, it makes it very simple. Mean and standard deviation are as before, and center for your tail to shade in. You're not really shaded in a left or a right, it's the middle. And then you're going to paste that, and I'm getting two answers, negative 1.28 and positive 1.28. Like I said, they will be negations of one another. Doing this function on the older calculator does require a little bit more work. If you need any help on that, please email me. But I put that document up in Brightspace in the lecture. This is lecture 12. I put it in the lecture 12 module, so you can have access to that if you need to know how to do that. I'm sure there's also resources online that could teach you how to do these questions as well using the TI-84. Okay, let me go to the calculator and do this middle one. Second distribution, inverse norm, the middle 80%. I could leave that as 0.8, by the way, 0.8, 0.80, it's the same thing. We're going to highlight center, hit enter, go down to paste and hit return. And you do get two z-scores coming out, one for the left and one for the right. So round to two decimal places, negative 1.28 and positive 1.28. Okay, let's do another type of problem. This time we are not going to be using z-scores. We're going to be using the actual data values from the distribution. And this distribution measures recovery time for a certain surgical procedure. So we have a particular surgical procedure that's got a recovery time, and that's our continuous variable. It's normally distributed, so we're going to use the bell curve. We are provided with the mean and standard deviation of the distribution, 75 and 5. So this puts the center at 75 and 5. So this is not a z-score question. We're dealing with the actual data values here. So we're going to put the actual mean and standard deviation in the center. And let's look at the question. Find the recovery time that cuts off the top 25% of recovery times. So let's remember that all 100% of recovery times are covered in the entire bell curve. The top 25% is just that piece on the right. Represents the 30th percentile. So we're going to find the recovery time that represents the 30th percentile. Find the recovery time that has a percentile rank of 55. And find the recovery time that cuts off the middle 40% of recovery times. So this part D is going to have two answers because the middle has two cutoffs, one on the left and one on the right. So let's take a moment and talk about B and C because they're both using percentile terminology. Let's recognize that when B is asked, when we are asked about the 30th percentile, this is also known as, AKA, the bottom 30%. And C, just phrased slightly different, but really still means the same thing, AKA, known as the bottom 55%. Okay, so if a question asks about gives you the percentile, it's the 30th percentile, or gives you the percentile rank, 55, that represents the percent of area to the left of the unknown score, the unknown recovery time that you're looking to find. So B and C are going to have area being shaded to the left when we draw a picture. A is going to have area shaded to the right. D is going to have area shaded in the center. So let's do those problems. Every problem we get, we're going to have recovery times are what the calculator is going to output for us. It's not going to output z-scores. So we are going to round our recovery times to two decimal places. Okay, top 25%. So making a picture of what the top 25% looks like. Let's also recognize that when we're talking about recovery time being at the top of the curve, these are longer than average recovery times. Average is in the center, top is on the right, so these are longer than average. This is average. High recovery times in this scenario are less favorable because sometimes being on the right side of the curve is a good thing. In this case, it means it took longer to recover. So let's do our best to shade the top 25%. And this is going to be the area to the right of this vertical line. And the question's asking us to figure out what that recovery time is on that vertical line. So we're going to do 0.25 on the calculator, 75 and 5 as our mean and standard deviation. And we want to make sure we choose the right direction. That is to the right, because we're talking about the top of the curve. And hit enter. 78.37 days. And let me verify my work. Second distribution, inverse norm, 0.25, 75 and 5. Right, paste, 78.37 days. Okay, so we got that right. Okay, let's look at the next question. B and C are really going to be solved in much the same way, so we'll do that in one shot, and then we'll go to the calculator and verify the numbers correctly. So the 30th percentile I said before is also known as the bottom 30%. So we're going to make a shaded area that blocks off the bottom 30%, and that's the fastest 30%. These are the patients who recover the fastest, and the remaining group, there's 70% of patients outside of that bottom 30%. We're finding the cutoff between the bottom 30 and the top 70. Okay, same mean and standard deviation as before. Do your best to shade off the middle, shade the bottom 30% and find the score by entering 0.30, 75, 70, and left into your calculator. So when we paste that, we're going to get 72.38 days. Okay, so 72.38. Recognizing that the center is where 75 is, and my value here, 72.38, is on the left of center, it makes sense that it's lower than 75. So that is a reasonable answer. Now let's do the 55th or percentile rank of 55 in the same way. Percentile rank of 55 is also known as the 55th percentile or the bottom 55%. So bottom 55% separates that group from the top 45%. So when we draw this picture, recognize that we are shading in the left again, but this time we're shading in more than half of the curve. So this is what it's got to look like. Recognize that half the curve is in the middle. Okay, so this is 50%, the bottom 50%. If I want to shade in the bottom 55%, then I've got to shade in more than this area. Okay, remember, this extends to negative infinity, so I can't make more on the left. I've got to find out where the 55th percentile is. So that's going to be a little bit more on the right. So you're going to shade a little bit more past the halfway mark to get 55% of the area shaded in. Okay, so there we have 55%. That's the bottom 55%. So the question is asking us to find this value right here. Remember, 75 is in the center, so I'm trying to find a number that's greater than that. So I'm going to put in 0.55, 75, and 5, Again, area to the left. And now I'm expecting a number that comes out more than 75, and it is 75.63 days. So let me go to the calculator and I'll demonstrate the bottom 30 and the bottom 55. Okay, let's do the bottom 30. Left, paste, 72.3, let's see, 38. Yep, that's what the slideshow had. And let's do bottom 55. Leftmost 55, 75.63. Okay. So the last question in this group is about the middle, and it says the middle, what are we going to do? The middle 40%. So let me go to the slideshow. Okay, the middle 40%. This is the middle of the curve. There's going to be 20% of the patients recovering faster and 20% recovering slower. I'm sorry, let me just double check what I mean by that. I should add here 20% recovering faster than the mean. I should be clear there. Than the mean, than mu, and 20% recovering slower than mu. And the reason why is because of the symmetry of this middle 40%. Because it's symmetrical, we have 20% on the left side of the mean and 20% on the right side of the mean. Okay, so that's not necessarily important, the 20 and 20. What we need to recognize is that we're being asked to find two recovery times. One is going to be lower than 75 and one is going to be higher than 75. So we're going to put into our calculator 0.40, 75, and 5, hit center, and we're going to get two numbers, 72.38 and 77.62. And let me do that and show you. So second distribution, inverse norm, 0.40, change the tail to say center, and paste, 72.38 and 77.62. Okay, we're going to have just a few more practice problems like this. A lot of the lecture is just more of practice. And so you'll be able to do your homework when you see these questions. You'll be able to do your homework with no problem. The difficulty comes when we mix up the questions from the previous couple of lectures with this lecture because sometimes students find it hard to identify the differences. But with a little bit of practice, this should become easier for you. Let's look at daily steps for a healthy lifestyle. We found that daily step count of adults is normally distributed with the mean of 7,500 and a standard deviation of 1,200. Okay, normal distribution. The mean is 7,500. That's the number right in the center. And the standard deviation is 1,200. And these are steps. The minimum daily step count. Find the minimum daily step count for someone in the top 10%. Okay, so the top 10% looks like, okay, let me go through the questions first. The maximum daily step count for someone at the bottom or in the bottom quartile. And okay, so those are our two questions. Even though they're phrased slightly different than the previous question, they really are solved in exactly the same way. The thing that students sometimes get confused about is the use of the word minimum here and the use of the word maximum here, but it really is solved in exactly the same way. So let's do part A, the minimum daily step count for someone in the top 10%. Okay, the top 10% is the rightmost 10%. Okay, this is our top 10%. And we are going to solve this in the same exact way, but let me explain the use of the word minimum here. So everybody, all people who have step counts in the top 10% have a range of steps that go from this red vertical line to the absolute maximum, right? The top. So the range of steps, that range, which is this this double arrow here that I made, that range does start at this vertical arrow and it just at this vertical line and it just gets bigger, right, as it goes to the right. So the minimum value in the range is this vertical line, and the maximum would be some maximum point way out to the right. But the minimum is the vertical line. So that's what we're being asked for, the minimum, that vertical line. So it's the same, solved in the same way. We put our area to the right as 0.10, mean and standard deviation, and use right as the tail. And we're going to get 9,037 steps. Okay, that's the minimum. And anybody who does this and more is considered to be in the top 10%. Okay, this is the minimum for the top 10%. Anybody who steps this much and more is considered to be in the top 10%. Okay, let's look at the maximum daily step count for the bottom quartile. So let's remember that when we use the word quartile, we want to also think of that as the same thing as percentiles in multiples of 25. So quartile is a 25%, and the bottom quartile is basically the bottom 25%. So we are finding the bottommost or the leftmost 25%. So make a picture of the what looks like the bottommost or leftmost 25%, and the same concept applies here. When I make this vertical line here, I represent in the shaded area all the people with step counts that are in the bottom 25%. It goes from the lowest step count, this is the range, from the lowest step count all the way through to this vertical line. This vertical line is the maximum of the range. So the range is everything in this bottom 25%, and this vertical line is the maximum for that range. So that's the question. What is the maximum? What is that vertical line? That's what this question is asking you to find. The value, the step count at that vertical line. So again, you use inverse norm. We put in 0.25 bottom. So we're going to make sure that says left, 7,500 and 1,200 for the mean and standard deviation. And based on the fact that the center is 7,500, this value at the vertical line has to be less than 7,500. And what comes out to be, yes, it is 6,690.61 steps. Okay, so anything that uses the term quartile is in quarters, 25th percentile, that would be the Q1. And then remember that we also have Q3, that's the 75th percentile. Q2 is the median or the 50th percentile. So we want to be able to read problems and recognize when to use the percentiles for which quartiles. Okay, let's look at a problem for reaction time in emergency medical responders. The reaction time of emergency medical responders is normally distributed. The mean is 250 milliseconds, and the standard deviation is 50 milliseconds. So we have a mean and standard deviation and a normal distribution. And we are measuring reaction time. Slowest reaction time, slowest reaction time in the fastest 15% of responders. So don't, again, this may seem tricky, but really don't get tricked by it. It's very basic. First, shade in what piece of area we're working with. The fastest 15%, um, I think we may need to distinguish here. The fastest, let's make the bell curve. When you're dealing with with response time, fast responders have the shortest response times. So the fast response times are on the left side. This is the fast response times, and these are the slower response times. So over here at the very, very left of the curve, we have the fastest response times, and then it just gets slower and a little bit slower and a little bit slower and a little bit slower until it hits this vertical line, and we're going to call that the slow, oops, sorry. This vertical line is the slowest reaction time for this group, this bottom, let's shade it in, this bottom 15%. This vertical line is the slowest reaction time for the bottom 15%. And then they do get slower and slower and slower and slower, but this part of the problem, part A, is only asking us about this piece right here. So here's super fast, and then it just gets slower. And this vertical line here, it would be the slowest response time. We're trying to find that vertical line. So inverse norm helps us find the number on the horizontal axis, the unknown reaction time. And so we're going to go and we'll put in 0.15 and make sure it's left, because we're talking about the left side of the curve. 250 and 50 is your mean and standard deviation. And it should be less than 250, and it is 198.18 milliseconds. Okay, so let's look at the other side of this curve. The reaction time for the 6th decile. So actually, when I said other side, I didn't mean going to the right. In this case, because we're asked about a decile, we still know that we're working with the left side of the curve because 6 deciles is 60th percentile, and percentiles always refer to area on the left. And so this represents the bottom 60%. But when we make the bottom 60%, when we shade the bottom 60%, let me back up, recognize that the vertical line that we create has got to be on the right side of center, because center is the 50th percentile. So the 60th percentile must be a little bit more than that. Okay, so you're going to make your vertical line on the right side of center here and shade. Okay, let's do it right there. And we're going to shade everything down to negative infinity. Okay, so the reaction time at the 6th decile is the reaction time at that vertical line, that cutoff. So we're going to again use area on the left-hand side, 0.60, make sure it's left, 250 and 50 for your mean and standard deviation. And the answer there is 262.67. Okay, let's look at cholesterol levels. Cholesterol levels are normally distributed with a mean of 200 and a standard deviation of 30. So mean of 200 and standard deviation of 30 right in the center. What is the minimum cholesterol level of someone in the top 1% of the distribution? And what is the maximum cholesterol level for someone in the lowest 5% of the distribution? So when we hear top, we're thinking rightmost part of the distribution. And when we say lowest, we're looking at the left side of the distribution. And when it got a little tricky was when we were talking about reaction time. And when reaction time said the fastest 15%, we had to recognize that fast meant on the left side because fast response times are shorter response times. So that question was slightly tricky. When dealing with cholesterol levels, okay, top and lowest do mean the right and the left. Okay, top is on the right, lowest is on the left. So let's solve this problem. Top 1%, you're going to shade in the very top 1%, which barely can be seen, but it's up there. And so the cholesterol level that you're looking for is a very high cholesterol level, whatever that is up there. So you put in the area as 0.01, so 1% expressed as a decimal, 1 divided by 100 is 0.01. Mean and standard deviation as given to you in the problem, and use right, and then paste that, and you get 267.79. And let's look at the other side. The lowest 5%, low cholesterol is on the left. So shade in the lowest 5%. That's this piece right here. Okay, and so our area 0.05, mean standard deviation left, and paste that, and it is 150.65. Okay, next I'm going to do a body temperature question. Then I have a systolic blood pressure. I got a few more questions. A lot of this is repeat, so I'm really just practicing the concept here. Feel free to skip ahead if this is obvious for you. Okay, we're dealing with human body temperature and we're given a mean and standard deviation. I don't know why this tends to happen. Let me fix this. Okay, we're given a mean and standard deviation. So in the center, we have 98.6 and a standard deviation of 0.7. What is the body temperature of someone at the 25th percentile? What is the body temperature of someone at the 90th percentile? So we know that percentiles start here. Like you could think about that as the first percentile at the very, very left. And you could think about the largest percentile at the very right, like the 99th percentile. So the 25th percentile may be somewhere around there, and the 90th percentile may be somewhere around there. Those are the two values that we're going to be asked for in A and B. So with A, again, we're always dealing with area on the left when we're referring to percentiles. So the 25th percentile is also known as, AKA, the bottom 25%. Bottom 25%. And the 90th percentile is also known as the bottom 90%. So let's do the bottom 25%. So shade in as best you can the bottom 25% and realize that the question is asking you for that cutoff at the vertical line. So you put in 0.25, mean 98.6, standard deviation 0.7, tail left, and paste that, and it's 98.13. Okay, you expect a number less than 98.6 because the values on the left of 98.6. Now that's for the 25th percentile. That's the bottom 25%. And the next part was the 90th percentile. The bottom 90% looks different. That shades in almost all of the curve, right? 90% of the curve. And we're shading the bottom 90%. That's everything to the left of this vertical line right here, which is what you're being asked to find. That's going to be a body temperature that's higher than 98.6. Anything that's at a high percentile is going to be greater than average. Any higher percentile than 50, the 50th percentile is going to be more than average. So you use inverse norm, 0.90, 98.6, and 0.7. Again, it's a percentile, so you're working with area on the left. And you're going to get, let's see, we're going to get 99.5. I want you to recognize here that 90% of area on the left is going to yield the same kind of answer as 10% of area on the right. So if I make this picture 10% and I compare it with the answer I get from this picture, where this is 90%, in inverse norm, if I use bottom or left, I'm sorry, I didn't mean to say that. If I use the top or the right with 10% and I use the bottom or the left with 90%, the same answer will come out on the calculator. The same answer where that question mark is in both cases. So I'll demonstrate this just to show you that it does work that way. Okay, let me use inverse norm. And I'm going to use, this time I'm going to do 0.90 first. 98.6 and 0.7. And I'm going to do left. Okay, 99.49. Approximate, 0.497, which rounds to 0.50, so 99.50. And let's do inverse norm with 0.10 area on the right. And it's the same exact number. Okay, so inverse norm is flexible like that. You can do either side. When the problem provides you with the word percentile, you understand it to mean area on the left, but you can easily subtract from 100 and recognize the other percentage is the area on the right. Okay, let's look at systolic blood pressure in women. We're looking at women in a particular age range, and we have a normally distributed set of blood pressures with a mean of 130 and a standard deviation of 15. So we're going to label our bell curve with the center at 130 and a standard deviation of 15. And we're finding the minimum systolic blood pressure of the top 2%. So that's going to be up here. The top will be up here. And a hospital wants to provide additional services to help women with systolic blood pressures at the third quartile or greater. What would be the minimum systolic blood pressure required to be recommended for additional medical diagnosis? So third quartile and greater, let's remember that third quartile or Q3 is the 75th percentile. Okay, part A, let's work on the top 2% first. So we shade in the top 2% of area. The vertical line is the blood pressure we're looking to find. So area, remember 2%, 2 divided by 100 is 0.02. So I'm going to put in 0.02 for area, mean, and standard deviation. I'm shading to the right because it says the top 2%. and I'm going to get an answer 160.81. Very high. Okay. Now let's also now think about that this next problem, part B, is also talking about high blood pressure, but it uses percentile in the way the problem is phrased. So it actually provides the area to the left, even though we're talking about high blood pressure. So let's look at the phrasing again. We're going to provide additional services to help women with blood pressures at the third quartile and greater. So before solving it, let's recognize that the third quartile is the 75th percentile. And a picture of what the 75th percentile is looks like this. This number at this vertical line is the number at the 75th percentile. And the problem, let's go back to the problem. Third quartile and greater refers to blood pressures that are at the 75th percentile and more. So everything to the right of that vertical line are the people that are being recommended for additional medical diagnosis. So we are asked to find what that number is. That is the minimum of the minimum blood pressure for people in this range. This is let's consider this people that really need additional help. And the vertical line is the minimum, the cutoff. Okay, so that's why we use the phrase here, minimum. And everybody in this range is going to be recommended for additional medical diagnosis. So we use inverse norm, 0.02. I'm sorry, this is wrong. Third quartile, that's the wrong picture. Let me go to the calculator. We're going to be putting in 0.7. Okay, so we're going to be putting in inverse norm. Let's put in third quartile or 0.75. And the mean we were given is 130 and the standard deviation is 15. And since this is the 75th percentile, we are going to change that to left. Tail is going to be left and paste this. And I expect to have a blood pressure more than the mean. Okay, 140.12. Okay, so while I do have the right answer in the slideshow, I have the wrong picture, so I will fix that. Okay, so 140.12. Body mass index. We have a normal distribution of body mass index, and the mean is 27. The standard deviation is 4. So that's the center of our distribution. And we're talking about the top 10%. Let's find the BMI that separates the top 10% from everybody else. So top 10% is on the right. And let's find the BMI that corresponds to the median. And really, I'm just testing your terminology here because there's very little work to be done with part B. And let's get the BMI. Sorry, what's going on here? Let's get the BMI for the third decile. I am losing my, okay, here we go. Third decile. My pen is glitching out on me, so it's not, okay, there we go. Okay, also known as, AKA, the third decile is also known as the 30th percentile. And we're going to round to 2 decimal places. Okay, let me try to get my pen working here. Okay, the top 10% is on the right. We're going to shade in the topmost 10%. This vertical line is what we're being asked to find. That's the BMI we're being asked to find. The mean is 27. The standard deviation is 4. the vertical line is going to be more than 27. So let's put in 0.10 on the right. 27 and 4 is our mean and standard deviation, and it becomes 32.13. Okay, let's take a look at the median. The median in a normal distribution is the same as the mean. So there's very little work to be done here. Since the mean and the median are the same value, the answer to the question is 27. But if you want to do the work and actually, this is so annoying. If you want to do the work and see how inverse norm can provide that answer to you as well, you can use inverse norm with an area of 0.50 because the median is that line at the very center. It separates the bottom 50% from the top 50%. So you could think about this as the leftmost or bottommost 50%. So if you put in 0.5 and you do 27 and 4 and left, you will get 27 as your answer. So if you understand that, you don't even have to use the calculator, but the calculator can confirm that answer as well. And let's look at the decile problem, the third decile. We're finding the BMI for an adult at the third decile. So the third decile is the same as the 30th percentile. 30th percentile means that you're looking at 30% of the leftmost area, the bottom area. So shade in the bottom 30%. Your vertical line is where the BMI that you're trying to find is. So you use area 0.30, make sure it's left. Mean and standard deviation are 27 and 4. And oops, this is way wrong. Hold on. Okay, let's try this again. This would be 0.30, 27, 4, and left. And this is 24.90. I'm going to write that in the slideshow. Okay, 24.90 is the right answer here. And okay, and that is our last question. So most of the time, these questions are obvious. When it says top, it's talking about the right side. When it says bottom, it's working on the left side. When it uses deciles, percentiles, or quartiles, you're also talking about the left side. The only case where it does get a little tricky, and we saw it with reaction time. So these questions were a little trickier about reaction time. So if the question says, find the slowest reaction time and the fastest 15% of responders, we have to recognize that the fastest responders, those that respond quickest, are actually on the bottom of the curve. Okay, so these people are the fastest, and the slowest are on the top of the curve. So that may make some students a little, or rather make you miss a particular type of question. Making a picture is always going to be helpful. To recognize the fastest 15%, realize that these people down here have the quickest response time. And over here, the one at the very, very leftmost, this is the quickest response time. And then response times get slower and slower and slower until it hits this point. And we say that that is the slowest reaction time for the top, or I'm sorry, for the bottom 15%, the fastest 15%. Similarly, a question that asked about the slowest 15% would be this group up here. And this vertical line would represent the fastest time for the slowest 15%. So it makes things a little bit trickier when you think about this, but with practice, this is going to become more and more obvious. And when you see this on a test with enough practice, you'll be able to get this kind of question with no problem. So that's it for our triple lecture on the normal distribution. We're going to go into sampling distributions next, which are based on the normal distribution. So we needed this as a introduction, and then we're reaching the end of the course. So I hope this was helpful, and let me know if you have questions, and I'll see you at the next lecture.